Hi, everybody. Today, what we're going to do is we're going to put all of those sign number rules together, and we're going to apply the order of operations, to sign numbers. So let's get started. Now, we've already done the order of operations, so I'm just putting in parentheses with sign numbers just to show that we're doing something a little bit different. But your rules for the order of operations are not going to change. So they're exactly the same as they always have been. It's just that now we're going to apply them with integers as well. And again, right now we're just focusing on integers. We're not going to bring in a lot of fraction or decimal work just yet. We will get to that soon enough. So we're going to focus there. Now for the order of operations, let's review the procedure. So the first thing you typically do is you're going to perform all operations inside any sort of grouping symbols. So typically these are parentheses, but they could be brackets. We've seen absolute values now, and so on. So also roots or radicals, which we'll see in a little bit. So any sort of grouping symbol. Again, typically they're going to be parentheses, but any grouping symbol would apply here. So your second step is to clear out any exponents that you have. So to do any of those powers. Your third step is to multiply and divide. And remember, you have to work from left to right. That's really important. So multiplication and division are equals. They go together. So whatever one comes first in the problem, you do that first. And then last, adding and subtracting. So we'll just say adding and subtracting. And just like before, you're going to work from left to right there. So those are equals. It's really important to just go in order of the problem. Now, some students remember the order of operations using that acronym Pemdas. So you can remember it here. So P stands for parentheses, but again, any grouping symbol is included. And you want to remember that you're doing inside the grouping symbol. So sometimes we use parentheses for multiplication. That's not what we're talking about here. We're talking about when there's something to do inside the parentheses. Next, you do your exponents. Then you have your multiplication and division, and you're adding and subtracting. And again, just be careful if you're using this PEMDAS, or please excuse my dear Aunt Sally. That's another one people often learn. Just remember that, MD and AS, they do work left to right. So multiplication does not always come before division, and adding doesn't always come before subtracting. This is just a way to us to generally remember the steps. So just keep that little warning in mind there. Now, the other thing you may want to review as well are all your rules for your different signed numbers, right? So if you're not comfortable with the signed number rules yet, you may want to stop this video at this point, go back and rewatch all the videos on adding and subtracting, multiplying and dividing signed numbers, because you're really going to need to know those rules very, very well in order to do okay in this section, right? Because we're putting all the rules together. So if you don't know them, you're going to really struggle here. So pause if you need to, go back and review those videos and do some practice if you need to before you come back to putting it all together. So I'm just going to do a very quick review of the rules for sign numbers here as well before we get started. And again, this is something that you may want to just put on an index card, like a little note card, and keep it with you for now until you get really, really comfortable with them. They should be automatic. So you want to get to that point where you're not even thinking anymore. It's just like you're getting the answers really quickly. That's the point you want to get to with sign numbers. And because we're going to work with them all semester. So if you're struggling on the rules here, you're going to make mistakes on other topics. So you really want to make sure you have those down pat. So the first one is addition or adding. And there are two rules here. So if you have the same signs, we just add the numbers and keep the sign. So for example, 4 plus 6 stays positive 10, or -3 plus -2 becomes -5. So if you have the same sign, you just add and keep the sign. If you have different signs, this is the tricky one, you're going to subtract the numbers and take the sign of the number with the larger absolute value. Or another way we thought of before is whatever there is more of, right? More negatives, more positives. So let me do an example here. So let's say you have -8 plus 4. So here I have different signs, one negative, one positive. I'm going to subtract. 8 minus 4 is just 4. And absolute value of -8 is bigger than the absolute value of 4. So what happens is there are more negatives, right? I have 8 negatives and only 4 positives. So this is going to stay negative. Another example, let's say I had a +6 plus a -4. Again, I have different signs, so I'm going to subtract. I get 2. Here I have 6 positives and only 4 negatives, so it's going to stay positive. Now for subtracting, we didn't actually have any really real rules. We changed this to addition, remember. So what we do is we change to addition and change the next number to its opposite sign. So another way to remember this is to keep, change, change. So you keep the first number the same, change it to addition, change the next number to the other sign. So for example here, if I have 8 minus 9, I'm going to keep the first number the same, change my minus sign to addition, and that +9 becomes negative. And now you just use your regular adding rules. So we get -1 here. Or for instance, let's say if I had -4 minus, minus -5, -4 stays, that minus sign changes to addition here, and then -5 becomes positive. So now I have a +1 in this case. Okay. Or I'll do one more. Let's say we have 2 minus -3. Again, my first number stays the same. Subtraction changes to addition, and then my negative changes to positive. So I have +5. And actually, I'll go to the next page here. I was hoping to fit them all on one page, but do one more and we'll move on. So this is your easiest one. With multiplying and dividing, remember that your negatives cancel in 2's. Okay. So if you have a positive times a positive or a negative times a negative, you get a positive answer. Or if you have a positive divided by a positive, or a negative divided by a negative, again, you also get a positive answer back out. If you have a positive times a negative, or a negative times a positive, get a negative out. And if you have a positive divided by a negative, or a negative divided by a positive, then you get a negative back out. So they cancel in twos. If you have two negatives, they cancel out. So for example, if I have -6 times -2, I would end up with positive, 12. Two negatives cancel out, I get a positive, and 6 times 2 is 12. If I had something like -8 times +3, well, 8 times 3 is 24. I only have one negative, so it stays. For division, let's say I have -12 divided by -4. So I have two negatives, they're going to cancel and become positive, and 12 divided by 4 is 3. Or let's say I have something like 6 divided by -3. Well, 6 divided by 3 is 2, and I only have one negative, so it has to stay. Now, also watch out for your exponents here, right? So we did a little bit of work with exponents and being careful. So let's say I have -3 in parentheses squared. So remember, if you have parentheses, the whole thing is being squared. So that whole thing gets rewritten. -3 times -3 becomes +9. If I have -3 squared, well, what happens is this negative just tags along on the outside, and then that 3 squared becomes 3 times 3. So here I only have one negative, so it does not cancel, and it tags along. If I have -2 to the third power, again, I have parentheses, so I'm going to write that out. 3 times. 2 times 2 times 2 is 8. And what happens here is two of my negatives will cancel, but I still will have one negative left over. So my answer would be -8. Or something like -2 to the third power. Here, my negative is outside, so I just tag that on. And then I have 2 times 2 times 2. And again, here that negative tags on. So these end up both being -8, but for different reasons. All right, so that is my review. Hopefully, again, you're feeling ready to go on further and do some more examples. So let's actually get started. I'm going to just go to a clean page here. All right, so let's just do another exponent example. Here I don't even have any negatives, just kind of a review. So if you need to, what you can do is keep out the first couple pages of your notes. Write down those order of operation rules again. So just going to go through the list every single time, one step at a time. Are there any grouping symbols? Are there exponents? Then multiply, divide, then add and subtract. So here I don't have any grouping symbols, but I do have an exponent. So I'm going to go ahead and do this exponent piece first. So that's 4 times 4, which is 16. So I end up with 2 times 16, which is just 32. Maybe if I want to bring in a negative here, I could do something like 2 parentheses -4 squared. So notice that there's no symbol in between, but that automatically means multiplication. I do have parentheses, but there's nothing to do inside, right? This parenthesis is just here to show that I have a negative. So there's nothing to do inside, and I'm going to move over onto my exponents here. So here I have -4 times -4, which also happens to be +16 in this case. So I end up with the same answer, but again, it's a different way that we get there, right? It's not the same strategy. All right, let's do another example. Just keep doing a bunch of different kinds of examples here with order of operations. I'll start simple and get more complex. So maybe we have something like -8 times 3 over -2. Now here I have multiplication and I have division. Typically when we have fractions though, we clean up the numerator first and then the denominator and then do the division at the end. So remember that fraction bar is also a kind of a grouping symbol in the sense that you want to do the numerator first, the denominator, and then do the division at the end here. So up top, I'm just going to do 8 times -3, which is -24, and then I just have a -2 on the bottom. Now I'm going to go ahead and divide. 24 divided by 2 is 12, and my two negatives here do cancel out. Negative divided by a negative becomes a positive. So now you can see that knowing those rules is important, right? Because I'm not spending so much time thinking about my sign rules. I'm trying to process through the order of operations here. So you really do want to know those sign rules. All right, how about -18 plus 6 over -3 minus 1? Again, I have that fraction bar, so I'm going to do my numerator and denominator separately. I don't have too much going on, though. I just have addition in the top. So -18 plus 6 is going to be -12. I have different signs, so I subtract those values. And I have more negative, so it stays negative. In the bottom here, we can rewrite this. So if I see subtraction sign, I can keep the first number the same, change it to addition, and change that 1 to -1. So I'm going to get -4 then for my answer. Now, other students like to do that keep, change right in the problem. That's fine too. So keep the -3, change to addition, change +1 to -1. So you could also do it right on the problem. Just make sure you're nice and neat. And then now my two negatives cancel, and I just have 3. All right, so another example here. Again, I have parentheses, but nothing on the inside. So that's what the grouping symbols really are for. So I'm going to move on from that. And I do see I do have to do my exponent first. So I have parentheses around the exponent, so the whole thing is getting multiplied out, in this case, 3 times. So 2 of my negatives will cancel. I'll still have 1 left over. And then 3 times 3 is 9, times 3 is 27. So my problem becomes 90 plus 20 plus -27. Now I just have addition left, so I'm just going to work from left to right here. 90 plus 20, that is 110. And now I have different signs, so I am going to subtract. So you may want to go do this off to the side. Now when you subtract, don't worry about what's positive or negative. Just set it up like a regular subtraction problem first. So you'll have to do your regular borrowing that we've done. And then go back and think about the sign. So here I have 110 positives and only 27 negatives. So there's definitely more positives. So my answer will be positive here. All right, so another example. Here I do actually have a true parenthesis where I can do something on the inside. So I'm going to do that first. I see subtraction, so I'm going to do the keep, change, change. I'm going to keep the 6 the same. I'm going to change it to addition, and I'm going to make that +10 a -10. Now I'm doing it inside the problem here, but if you want to rewrite it, you can rewrite that step. So do whatever's easier for you. Now 6 plus negative, so this is 6 plus -10, right? So I have different signs. I'm going to subtract to get 4. I have more negatives, so this becomes -4. Now I do have parentheses here, but there's nothing to do on the inside. This one here represents multiplication. This one here is just to clarify a negative. So sometimes we put parentheses around negatives, other times we don't. So this one I don't have to do anything with. I do have to multiply these though. So after parentheses would come exponents. I don't have exponents. So next is multiplication and division. -3 times -4, my two negatives cancel. I have +12. And then I'm just going to bring everything else down. So I do have a minus sign there. I do adding and subtracting going left to right. So +12 plus -4 is a +8. And then here I just have 8 minus 5, which is 3. Now, if you want to do that, keep change, you can there. But 8 minus 5 is just a regular subtraction, so we can do it that way as well. I'm just going to do a couple more examples. And again, we could do hundreds of these, right? We're just kind of going through a few of them again. So let's do -3 times the absolute value of -8 minus -4 plus 5 squared. All right, divided by -5. All right, so let's get started here. I do see some parentheses, but these two really just mean to clarify we have a negative. However, I do see an absolute value. An absolute value, if there's anything to do on the inside, you would do that first. So the only thing I can do here with the absolute value is I can clear this out. The absolute value of -8 is +8. So remember, these vertical lines are absolute value symbols. This becomes +8. So I'm just going to rewrite this. So my parentheses on the inside are all done. I'm going to do my exponent next. So this is 5 times 5, which is 25. And my exponents are done now. And I'm going to move on to multiplying and dividing. I'm going to do this from left to right. So I do see some multiplication here, and then I also see some division here. And they're not touching each other, so I can just go right in order left to right. I'm going to do these both in the same step. -3 times 8 would be -24. And then 25 divided by -5 would be -5. Notice that I'm just being careful to stay everything else in order and bring it right down. All right, left, I see subtraction and addition, so I'm going to work from left to right here. You really want to be careful that you don't change up the order or else you'll get the wrong answer. So here I see we're subtracting a negative. So I'm going to keep, change to addition, change this to +4. And again, if you find that too messy, then you can just rewrite it. -24 plus +4 is -20. I'm going to bring down this -5, and I get a final answer of -25. All right, so here's one last example on order of operations. And again, at any time throughout the video, if you want to pause this, try it on your own first, see if you get the same answer as me. That could be good practice for you. So here's where we have parentheses inside of brackets. So when you have grouping symbols that are nested like this, it's called nested, one inside of another, you work inside to outside. So I'm going to start right here on the innermost parentheses. I do see subtraction, so I'm going to change it to addition. I'm going to change that +8 to -8. And I'm going to simplify that first. So let's just rewrite everything else, being careful to stay in order. 5 plus -8 is -3. Now I know I have an exponent, but I have to finish this set of brackets first. Brackets are also included as grouping symbols. So I'm going to use the order of operations inside of it. So I do see addition and I see multiplication here. So the multiplication has to go next. 6 times -3 is -18. again, we gotta finish this piece here. So -1, and then I have -4 plus -18, same sign, so I'm just gonna add them. I get -22. And now I've done everything I can on the inside of that bracket, so I'm ready to move on. After your grouping symbols come your exponents. So I am going to go ahead and do my exponent next. You want to be careful, this minus sign is out front. It's just like a negative that's out front. Minus signs and negatives, you want to start thinking as being the same thing. They really are interchangeable. So it's not part of the square. It doesn't become a negative times a negative. It's not in parentheses. So what we have is a minus sign, and then this 10 squared is 10 times 10, which is 100. So I lost my 1 there, sorry guys. Here I'm going to go ahead and multiply. -1 times -22 is a positive 22. And finally, I'm going to change that subtraction over to addition, make my 100 negative. Now I have different signs here, so I have to subtract. So when I set it up, again, don't worry about what's positive, what's negative. 100 has to go on top if I subtract so that I can correctly borrow. So forget about the sign, just put the bigger number on top without the sign. And then that way you'll be able to go ahead and subtract. So now I get 78 and then go back and think about the sign. Well, I want more negative, so it's going to be -70 instead. So there's my final answer there. Okay. One other thing to note here is I did have a -1 out front. Sometimes we won't put the 1 in. So if you ever see something like a negative next to another number like this, so a negative next to a negative, just remember that means multiplication here. And then negative times a negative is a positive. So you can always put a 1 in if you need it, but it still works. 2 negatives cancel out and you get 22. So you may see it that way as well. All right, so the last thing I want to do is just a couple more examples with order of operations, but kind of taking it to the next step. So here we're going to evaluate. So let's evaluate. (2x squared minus y plus 4z for x equals -1, y equals -3, bring out of room, and z equals, we'll say +2. So remember, I'm just going to replace all of those variables with my values. So I have 2, and then I'm going to use a parenthesis when I evaluate. So I'm going to plug in that -1, and that x is being squared. So the -1, the whole thing is being squared. Don't forget your minus sign. And then my y value is -3. And my z value here is +2. And now you're going to apply your order of operations. So I do have lots of parentheses, but there's nothing on the inside to do here. So I'm just going to go ahead and keep simplifying after that. My next thing is my exponent. So let me use a different color. You want to be careful. You're not going to do 2 times -1. You need to do the exponent first here. So that is -1 times -1. So -1 times -1 is +1. So I have 2 times 1 minus -3 plus 4 times 2. All of my exponents are done, so now I'm going to move on to multiplication and division. I just have multiplication here and here. So 2 times 1 is 2, and 4 times 2 is 8. Finally, I have addition and subtraction left. So I can go ahead and change this over to adding a positive. And again, if you find that too confusing, just rewrite it. So we get 2 plus 3 is obviously 5. And then 5 plus 8 is going to be 10. So when we evaluate, we're still using our order of operations here. And I want to do one more example for you guys, so I'm just going through my notes. And let's do find the average temperature over the past 5 days. And our temperatures, so this may be given to you in a table or in a bar graph or something like that. I'm just going to give them to you here. But oftentimes we may see a table or a graph here, and that's fine too. So maybe the temperature on the first day, we'll just call this Monday, just keep it organized, was 10 degrees Fahrenheit. Maybe on Tuesday, it was 8 degrees Fahrenheit. On Wednesday, it was 2 degrees Fahrenheit. On Thursday, it was -5 degrees Fahrenheit. And then on Friday, it was -5 degrees Fahrenheit. So remember, for your average, the first thing you need to do is add everything up. So in my numerator, I'm going to add my 10, my 8, my 2, my -5, and my -5. And then we're going to divide by the number of things we've added. So I have 1, 2, 3, 4, 5 days here. So I'm going to divide by 5. And this actually is an order of operations problem because you do want to make sure that you're doing that numerator first, right? Just going to put parentheses to remind you, do that first. Where it's all addition, you can add in any order that you want. So usually students will add their positives together first if they can. So here I have 10 plus 8 plus 2 is 20. Here, if I add my negatives, I'll have -10. So 20 plus -10 is going to be +10. And then 10 divided by 5 is 2. So our average temperature is 2 degrees Fahrenheit. Now, for problems that have all addition, you can move things around because remember, we do have the commutative and associative properties. That does not hold once you bring in other operations. So if a problem is only addition or only multiplication for like a certain part, then you can rearrange. But you want to be careful once you have a subtraction or, we have division here, but because we're working on just the numerator, it's okay. But once it gets more complicated, you really want to follow order of operations. We only do rearranging if we're really sure that we can, right? So it's all addition or something like that. So just, again, one more application here of how you can apply the order of operations.